When we are subtracting with rational numbers, we never really want to subtract. Instead, we always want to change our problem to an addition problem, since we do know how to add with rational numbers. The rule for changing a subtraction problem to an addition problem is to add the opposite. So let's look at the example -5 minus 8. The first thing that I want to do is change this to an addition problem. So I'm going to change my subtraction sign to an addition sign. But that's not the only thing that I need to do. Remember that the rule says not to just add, but to add the opposite. That means that I'm going to look at the number behind my new addition sign, and in this case, that number is +8. I need to change that number to its opposite. I know that +8's opposite is -8, so I'm going to change this to -8. So, -5 minus 8 became -5 plus -8. And now that it's in addition, I know how to solve it. I see that I have like signs because they're both negatives, which means I would add their absolute values. 5 plus 8 is 13, and I would keep the sign of negative. So -5 minus 8 is equal to -13. Now let's practice. -4 minus -8. If I change this to an addition problem, I'm going to keep -4 the same, but I'm changing my subtraction sign to add. And then I need to change my second number to its opposite. This number is -8, so the opposite of -8 is +8. Now that I have an addition problem, I'm going to use my rule for adding to solve. I see that I have a negative plus a positive, so I'm adding different signs, which means I'm going to subtract their absolute values. So for this problem, I'm going to do 8 minus 4, which would give me 4. Then I would need to take the sign of the number with the greater absolute value. I know that 8 is greater than 4, so 8 has a greater absolute value and 8 is positive. That means that my answer is +4. Let's look at our next problem. 12 minus -10. I'm going to rewrite this, so I start with 12 because the first number does not change. I'm going to change subtract to add, and then I need to find the opposite of -10. The opposite of -10 is +10. Well, now this is just a normal addition problem where I'm adding positive numbers. So 12 plus 10 gives me 22. Let's look at -14 minus 5. If I change this to an addition problem, I'm going to keep -14, subtract will change to add, and then I need to look at this second number, which is 5. This is a +5, so I need to change it to its opposite, and the opposite of +5 is -5. So my new problem says -14 plus -5. I notice that I have the same sign, so when I have the same sign, all I have to do is add my absolute values. So I will add 14 plus 5, which gives me 19. And then I'm going to keep the sign, so my answer is going to be -19. 3 minus 9. If I rewrite this as an addition problem, 3 is going to remain the same. Subtract will become add, and then I need to change this number, which is 9, to its opposite. The opposite of 9 is -9. Now I have an addition problem where I'm looking at different signs. Since I'm adding with different signs, I know that means I need to subtract my absolute values. So 9 minus 3 is 6. I know that -9 has a greater absolute value than 3, and since this 9 is negative, that means my answer is going to be -6. -7 minus -4. I'm going to rewrite this as an addition problem. So it's -7 plus, and now I need to change -4 to its opposite. The opposite of -4 is +4. Now I have an addition problem, and I'm adding with different signs, which means I need to subtract my absolute values. So I'm going to subtract 7 minus 4, which will give me 3. And since 7 has a greater absolute value than 4, and 7 is negative, I'm going to make my answer -3. Next, I have -8 minus 15. I'm going to rewrite this as an addition problem, so -8 stays the same. I'm going to change subtract to add, and then I need to find the opposite of 15. The opposite of 15 is -15. Now I see that I have an addition problem with like signs, so I'm just going to add my absolute values. 8 plus 15 gives me 23, and I keep my negative sign. Now let's look at subtracting with decimals. This problem says 5.42 minus -2.9. I am still using my same rule, which is to add the opposite. So I'm going to rewrite this problem so that it's 5.42 because it stays the same. I'm going to change subtract to add, and then I need to find the opposite of -2.9. The opposite of -2.9 is +2.9. Now when I look at this, I'm adding 2 positive decimals, which means I'm just adding like normal. When I add decimals, I remember that I need to line up my decimals. So 5.42 plus 2.9. And in this empty space, I'm going to put a 0 as a placeholder. 2 plus 0 gives me 2. 4 plus 9 gives me 13. So I'm going to write my 3 and carry my 1. I'm also going to bring down my decimal. 1 plus 5 is 6, and 6 plus 2 is 8. So my answer is going to be 8.32. And since both of these were positive, my answer stays positive. Now let's look at -3.8 minus -0.245. I'm going to rewrite this as an addition problem, so -3.8 will stay the same. Subtract will become add, and -0.245 is going to become its opposite. The opposite of -0.245 is +0.245. And now I need to use my rule for adding. I see that I have a negative plus a positive, so I'm adding with different signs. When I'm adding with different signs, I know that that means I need to actually subtract my absolute values. So for this problem, I am going to subtract 0.245 from 3.8. I remember that I need to line up my decimals, and then I can subtract. Well, for this problem, I also need to have zeros as placeholders. Now, I notice that I cannot subtract 5 from 0, so I need to borrow from this, but there's nothing here to borrow, which means I actually need to come all the way over here and borrow from the 8. That will make my 8 a 7, and that makes this a 10. Now I can borrow from this to make this number a 10 and this number a 9. 10 minus 5 gives us 5. 9 minus 4 gives us 5. 7 minus 2 gives us 5. I'm going to bring down my decimal, and 3 minus 0 gives us 3. So when I subtract, I get 3.555. I need to look at my problem, which said -3.8 plus 0.245. Since these were different signs, I need to take the sign of the number with the greater absolute value. I know that 3.8 is greater than 0.245, so I'm going to take the absolute value of -3.8 sign. So that's -3.555. Now let's look at -7.9 minus 7.524. If I change this to an addition problem, it will become -7.9 plus, and now I need to find the opposite of 7.524. The opposite of this is -7.524. When I notice that I have 2 negative numbers being added, so like signs, I know that I can just add my absolute values. So I'm going to add 7.9 and 7.524. lining up my decimals and filling in empty spaces with zeros. 0 plus 4 is 4. 0 plus 2 is 2. 9 plus 5 is 14, so I write my 4 and carry my 1. I also bring down my decimal. 1 plus 7 is 8, and 8 plus 7 is 15. So when I add these, I get 15.424. But that was just adding the absolute values. I need to go back to my problem, which was adding like signs. I know that when I add with like signs, I add the absolute values, which is what I did, and then I keep the sign. So I need to keep the negative sign on my answer here. Now let's look at some fractions. This problem says 2/5 minus negative 3/5. To solve this, I'm still going to use my rule, add the opposite. So 2/5 would remain the same, subtract would change to add, and then negative 3/5 would need to change to its opposite. The opposite of negative 3/5 is positive 3/5. Now I can add my fractions. I see that I have the same denominator, which means I don't have to go through anything here, and instead all I have to do is add my numerators. So 2 plus 3 gives me 5, and then I keep my denominator of 5. And I know that I can simplify 5/5, which would make 1. Because I was adding two positive numbers, my answer is positive, so my answer is just positive 1. Now let's look at negative 3/8 minus 1/4. To change it to an addition problem, I'm going to keep negative 3/8 the same. I'm going to change subtract to add, and then I'm going to look at 1/4 and find its opposite, which is negative 1/4. Now I cannot go ahead and add these because I notice that they do not have the same denominator. So I'm going to find the least common multiple for 8 and 4, which I know is 8. So that means that negative 3/8 will not need to change since its denominator is already 8. But I am going to change negative 1/4 so that it has a denominator of 8. I know that my fraction is negative, and I know that I multiplied 4 times 2 to get 8, which means I'm also going to have to multiply 1 times 2, which will give me 2. Now I have common denominators, so I can add like normal. I see that I have two negative numbers, which means I have like signs. And the rule for like signs is to add the absolute values and keep the sign. So I am just going to add 3/8 plus 2/8, which means I'm going to add my numerator of 3 plus my numerator 2, which would give me a numerator of 5. And I'm going to keep my denominator of 8. Because these were both negative, my answer is also going to be negative, so my answer is negative 5/8. Now let's do negative 5/6 minus negative 2/3. To rewrite this as a subtraction problem, I'm going to keep negative 5/6, change subtract to add, and then I'm going to find the opposite of negative 2/3. The opposite of negative 2/3 is positive 2/3. Now I know that I'm adding these, and I know that I need to have common denominators to be able to add. When I look at these, I see that the least common multiple for 6 and 3 is going to be 6. That means that negative 5/6 will not have to change since it already has a denominator of 6. But 2/3 will have to change so that it does have a denominator of 6. To get from 3 to 6, I would multiply by 2, which means I would also need to multiply my numerator by 2. 2 times 2 will give me 4. So now my problem says negative 5/6 plus positive 4/6. I know that I have different signs here. Since I have different signs, I actually need to subtract my absolute values. So I'm going to do 5/6 minus 4/6. I'm going to subtract my numerator, 5 minus 4, which will give me 1, and I'm going to keep my denominator of 6. To figure out which sign I use, I'm going to use the sign of the number with the greater absolute value. Well, negative 5/6 had an absolute value of 5/6, and 4/6 had an absolute value of 4/6. 5/6 is greater than 4/6, so I am going to use 5/6 sign, which is negative. So My solution to this problem is negative 1/6.